Hi, my name is Octavio and today we're going to make this video for solving these problems for the chemistry class, for the chemistry exam class. And the first problem we got right here is the following one. A sample of hydrogen has an initial temperature of 35 Celsius. When the temperature is increased 2/3 of the initial temperature, the volume of hydrogen becomes 485 milliliters. What was the initial volume of the hydrogen? Okay, so for this problem, I already gave you the data. And for solving this problem, we are going to use the Charles law. What the problem is asking us to solve to found, it is the initial volume. Which one we don't know. And I already recovered the data from the problem. The problem tells us that the hydrogen is at temperature of 35 degrees. So we needed to convert it to change it to Kelvin. So for changing it to Kelvin, we need to do this equation, this thing that is 35 degrees, that is the temperature on Celsius that we got, plus 273.15. After doing that, we got 308.15 kelvins. In the volume 2, it tells us that we have 485 millimeters, and by changing it to liters, we need to have, for solving this, we need to have it in liters. We have 0.485 liters. And for the temperature 2, which one it was a little bit tricky to get, we need to do the following. First, it tells us that the temperature 2 equals to 2/3 of the temperature 1, and 2/3 of the temperature 1 equals to 205.43 kelvins. Then we need to add those 205.43 because it's telling us that the temperature 2 is 2/3 more than the first temperature. So we had 308.15, which one is the temperature 1, plus 205.43, which is the 2/3 of the temperature 1. And it gave us the result of 513.58 kelvins. Right, so what we're going to do now is to solve the problem and to get B1. The other thing, it was to get the values, which I already get, which were to get them from the problem and to change them to kelvins and liters, to the things that we want to get. Now, the formula we are going to follow for solving our problem to get B1, it is the following one. We're going to do this thing. V1 equals to temperature 1 times volume 2 divided by temperature 2, which one it is going to look like this. V1 equals to 308.15 times 0.485 divided by 500.58, and all of this is going to give us the result of P1, which one it is 0.291, and it is already in liters. So we got our final result, which one it is B1 equals to 0.291 liters. And that's everything for this problem, and we're going to do the next one. Right, so we are here in the next problem, which one it is the following one. If a gas is cooled from 323 kelvins to 273.15 kelvins and volume is kept constant, what final pressure will result if the original pressure was 750 mmHg? So what we need to do for getting the data, it is the following thing. The problem tells us that if a gas is cooled from 323 kelvins, which one it is going to be our first temperature. So in temperature 1 it is 323 kelvins. 323 kelvins. Then the pressure 1, it was the one of 750 millimeters of mercury. So what we need to do for getting this in ATMs, it is the following formula or the following thing. We're going to do 750 divided by 760, and this is going to give us 0.986. 0.986. We're going to get 0.96 ATMs. For the temperature 2, we are going to use the one that tells us, the second one that is in the problem, which one it was, 273.15 kelvins. Kelvins. And that's how we get the data. Now we are going to proceed to get the pressure 2. So now we are going to solve the problem and we are going to get the pressure 2. What we need to do is to follow the next formula. Sorry, I was wrong right here. Which one it is? Pressure 2 equals to pressure 1 times temperature 2 divided by temperature 1. And like with the numbers, it is the following thing. Pressure 1 equals to 0.986 times 273 divided by 323, and after doing this, the result it is 0.833. So we are going to write it right here, 0.833. P2 equals and that's everything with this problem that we do, and we're going to continue with the following one. And also I forgot to tell you that this was a Gay-Lussac problem. So this is how we solve a Gay-Lussac problem. And now we're going to do the last exercise, which one it is a ideal gas law exercise. And the problem says a container holds 1,200 milliliters of nitrogen at 49.7 Celsius degrees and a pressure of 1,236 millimeters of mercury. What will it be its volume if the temperature increases to 59 degrees? So the data that we got right here, it is the following one. The pressure, I already converted, but I'm going to explain to you. The pressure that it gave us in the problem, it is in another measure, so we need to change it to ATMs. And what we are going to do, it is the following one. In the problem, it gave us 1,236, which one it is 1,236 divided by 760, and that is going to give us 1.626 ATMs. Then we need to get the volume, so we don't know. I'm going to put a question mark because we don't know which one it is. The next one are the moles. For the moles, we need to do the following thing. In the problem, it told us that we have 1,200 milliliters of nitrogen, which converted to grams, it is the same amount of 1,200 grams. And we're going to put it right here, 1,200 divided by the molecular weight of the element that we have, this 1,200, the milliliters or the grams, and the element that we are going to use, it is nitrogen. The molecular weight of nitrogen, it was 14.007, like James Bond. And by dividing this, by doing this equation, we get 85.671 moles. Then we have the constant of the ideal gases, which one it is the same of the entire life, which one it is 0.082. And finally, we got the temperature, which one the formula that we need to follow it is the next one. We need to, the problem it gave us 49.7 degrees in Celsius, but we need to change it to Kelvins. Right here is already in Kelvins. And the formula for changing it, it is the following one. We got our Celsius 49.7 plus 273.15. And this is going to give us the temperature of 322.85 kelvins. That's the data, and now we are going to continue by solving the problem and to find the volume. And now we're in the last step, and we're going to solve the problem, and we're going to get the volume. How can we get it? We can get it with the following formula, which one it is. Volume equals to moles times the constant of ideal gases times temperature, and all of that divided by the pressure. And with the numbers, it will look like this. The volume equals to 85.671 times 0.082 times 322.85 divided by 1.626. And all of this is going to give us the result of 1,394.851 liters. And that's how you solve this ideal gas law. Thank you for watching, and I hope I get it in.